Good afternoon. Today we're going to talk about segments and congruence. So this is part 2 of your 1-2 notes. I need you to hit pause, and I'd like for you to go ahead and do the bell work. And when you are done, hit resume, and we'll go over the answers. Okay, so name a pair of opposite rays. So we need rays that start at the same point. So this point is going to be B. So we are going to have ray BD, and we are going to have ray BA. Apologize right now for my bad writing. I forgot my stylus, so I'm having to write with my finger today. So that will be interesting. All right, name 3 collinear points. Collinear means points on the same line. So point A, point B, and point D are all collinear. Coplanar, you could use any of those 5 points and they would all be coplanar. So you could list any of those 5 points and separate them by a comma. So if we have a plane and a line will intersect at a point. And if we have 2 planes that intersect, such as the ceiling and the floor, those will intersect in a line. Okay, so segments and congruence, you will need to copy the following 3 definitions onto your paper. So just take a minute, hit pause, and copy those definitions, and hit resume or play when you are ready to roll. So congruent means 2 or more things have the same measure. So sometimes we don't know what the measure or the length is, but we know that it's the same, and that's when we can use the congruent symbol. The congruent symbol is like an equal sign with a little squiggly on it. A midpoint, we talked about that yesterday in class, but it's a point which divides a segment into 2 congruent segments. It doesn't divide a line into congruent segments because lines go on forever, so you have to make sure that we say that it divides a segment. And a segment bisector actually goes through the midpoint, so it is a point, a line segment, a ray, or a plane that divides a segment at its midpoint. So when we talk about a midpoint is a point which divides a segment into 2 congruent segments. This little mark that you see here on these little line segments, those both have 1 hash, so that signifies that segment AM is congruent to segment MB, and the 2 segments have equal measures.
Luana, please report to the
All right, so what is a segment bisector? A segment bisector is a point, line, ray, or segment which divides a segment at its midpoint. So if we look at what's going on right here, this is the midpoint of this line right here. And this is a line DC right here that goes through that midpoint. So that's considered a segment bisector. Okay, it's not a point necessarily that divides a line into 2 congruent parts because that's the midpoint, but it is a line segment, ray, or plane that goes through that midpoint and divides the segment into 2 congruent pieces. And then how is the segment bisector different than a midpoint? The bisector actually goes through the midpoint. All right, the ruler postular actually just talks about distance. So remember that distance is always positive. If you think about a number line, just because you go left, that negative doesn't mean the distance it's negative. It means you're going left so many units. So just remember, anytime that we talk about absolute value, that we talk about distance, we use absolute value because distance is positive. So the ruler postulate is basically just verifying that. The distance is the absolute value of the difference between x2 and x1. Segment addition postulate basically says that if we have a line segment that has multiple pieces, I can come down here and I can take this green piece and I can add that to this yellow piece, and that will give me the length of the entire piece. Honestly, reading the segment addition postulate with all the letters is somewhat complicated looking, but if we do an example, it will all fall together. So let's just roll. Oh yeah, one other thing, when you look down here, if we come over here to the bottom right and we talk about what does it mean to have the little segment mark, if you have the segment mark, that means line segment, and without that little segment mark, we're actually talking about the length of that segment. So this example is not in your notes, but let's just talk about it anyway. So if we look and it says, hey, find the length of segment QR is this entire thing. So we're going to take this and this and add it together. So the length of segment QR is going to be 8 units. And here it says find ST, so ST is this missing piece. If we think about the math behind this, we know that ST plus 18 is going to give me 38. So with a little bit of algebra, I can subtract that 18 from both sides. And if I subtract 18 from both sides, then S is 20 units. Okay, on to the examples that are in your notes. If you don't have a picture, the best thing you can do for yourself is to draw a picture. So that is where I'm going to start. We have point M, which is between Q and R. So if I draw my line segment and I have a Q and an R, and I don't even know that M is in the middle, okay? M is just somewhere on this line. This particular problem does not specifically state that M is in the middle, so I'm just going to put it wherever I feel like, which was right where I put it. So QM is 2x plus 5, so this segment here is 2x plus 5, and MR is going to be 3x plus 12. And I know that the length of this whole entire thing is 37 units long. So the segment addition postulate says, hey, if I take 2x plus 5, that first piece, QM, and I add it to 3x plus 12, sometimes I like to go crazy and stack these. I think it's easier. If I add that, I get 5x plus 17, and I know that that equals 37. And now I can take this and solve for x. So if I move my 37 to the right hand, or my 17 to the right hand side and subtract 17, I get 5x equals 20. And divide by 5, so x equals 4. Make sure you read the problem because these will trick you. Right here, this problem says, hey, find QM and MR. So technically, we are not done with this problem. QM is going to be 2 times 4 plus 5. 8 plus 5 is 13. And MR is going to be 3 times 4 plus 12. 12 plus 12 is 24. And honestly, if you add those two numbers up, you can kind of do a little self-check because we should get the length of the entire segment. All right, moving on to example 2. I want you to take a minute, hit pause, work this one out on your own, and then we will check our answers. All right, welcome back. Let us do this problem. I will do it pretty quick since you should have already done it. So I know that if I take 6x plus 23, that should equal the length of my entire segment, which is 5x plus 28. With a little bit of algebra, that should be 28, not 2x. So I'm going to get my x's on one side. And if I solve that, I get x equals 5. So I can substitute x back in for AB. It's going to be 6 times 5, which is 30. And they actually asked for the length of the whole thing. So if I want the length of AC, I'm going to take 30 plus 23, and that's going to give me 53 units. I can also take this 5 and plug it in here and just verify that I get the same answer. 5 times 5 is 25. Add that to 28, and I also get 53, so I feel pretty confident that 53 is the correct answer. All right, rolling right along to problem number 3. Problem 3 is very similar, so to the previous two problems, I want you to hit pause, and I just want you to work through it. And when you are done, go ahead and hit resume. You guys are working so fast today. Welcome back. So if we take 3x minus 1 and I take 6x plus 3 and I add them together, I get 9x plus 2. In my problem right here, they told me CE equals 29. So this equals 29. Move my 2 to the other side. So 9x equals 27. Divide each side by 9, and x is going to equal 3. Again, they don't want x. They want the length of CD. So CD, I'm going to come back up here, and I'm going to plug that value of x in. So 3 times 3 minus 1, and 9 minus 1 is 8. So the length of CD is going to be 8. All right. So, example 4. A, B, and C are collinear. Point B is between A and C, and they give you the length of the 3 segments. So, let's draw our picture. We're going to draw a line segment. B is between A and C, so again, B is somewhere between A and C. They're not super specific about where, so just get yourself a visual going on. All right, so if I continue to work this, I know that AB is negative 22 plus 2x. I know that BC is 12, and they tell me the length of the entire segment is x plus 2. So, if I will use the segment addition postulate, negative 22 plus 2x plus 12 is going to give me negative 10 plus 2x. And that equals the length of the entire segment, which is x plus 2. If I do a little math, and your math may look different than mine, I get that x is 12. And if I want the length of the entire segment, AC, that's going to be 12 plus 2, which is 14. All right, last example. So looking at example 5, I will tell you when you do problems to highlight key vocabulary words because it helps keep you from missing things. The key vocabulary word in this particular problem is midpoint. So every other problem in this assignment gave us the length of the entire segment, but here I don't have the length of the entire segment. So if I think of this as a midpoint, what that actually tells me is that the 2 segments have an equal measure. So that literally tells me that if I come into this problem, I know that 3x plus 7 is going to equal negative 2x plus 22. Okay, so midpoints form congruent segments, and congruent segments have equal length. So now if I move my 2x over here, do a little algebra, you should not copy mine, you should do this on your own. Move my 7 to the other side, and hopefully x equals 3. So now I can substitute 3 back in for x, so Rm is going to be 3 times 3 plus 7, and ms is going to be negative 2 times 3 plus 22. And if I work both of those out, regardless, they both end up being 16, so it doesn't matter which one you did, but because they should both be the same. Now, if you look at the problem, I'm actually technically not done with this problem because they want me to find RS, which is the entire segment. So if this is 16 and this is 16, then the actual length of RS is going to be 32. It's a huge ACT thing, so always look, especially on the geometry questions, but you should really do this for all math questions and make sure that you answered the question. All right, hopefully this is enough information that you can do your distance and midpoint homeworks, 1-2.b. Have a wonderful day, and I will see you in class tomorrow.